Good morning, class. I am your teacher, Sir Ricardo Pincaro. And for today, we are going to discuss a particular uh, part of the electromagnetic spectrum, which is light. Okay? So light is said to be a particular uh, radiation or an electromagnetic wave, which is said to be the only electromagnetic wave that may be found in the spectrum which can be visible to the naked eye, or meaning this is the only particular radiation or the electromagnetic wave that can be seen by our own eyes. Now, before we go on with our main topic for today, we're going to have a short game taken from a particular game show from the television, which is known as the fact or bluff. Okay, so we have fact or bluff. Okay, first question. The image formed by a plane mirror is a virtual image. What do you think is the answer? Fact or bluff? If your answer is fact, then you are correct. Okay? Second one. The angle of incidence is always equal to the angle of reflection. What do you think is our answer? The answer is fact. Okay. So number 3. A high gloss paint exhibit diffused reflection. What do you think? Fact or bluff? The answer is it's a bluff. You will see later why it's a bluff. Okay? Number 4. Refraction is the bouncing of light rays when it strikes a reflecting surface like that of a mirror. Fact or bluff? The answer is it's a bluff. The last one. If a man stands 4 feet in front of a plane mirror, his image distance is the same. Fact or bluff? Answer? The answer is a fact. Okay? So, always when you stand in front of a mirror, of a plane mirror, your image formed in the plane mirror will always be having the same size. You're having the same figure as you are, and the distance between you and the mirror. Okay? So this is how is that? When you are standing in front of the plane mirror, you will be having the same feature. Your image will be having the same feature as you are. It also have the same distance and the same height. Next. In the discussion of the mirrors, there are 2 types of reflection. First, okay, these are the 2 types of reflection. The specular reflection and the diffuse reflection. The specular or regular reflection, it is when light rays are reflected in one direction. Okay, meaning these light rays passing through or from the source, when it strikes the surface of the mirror, it will have a uniform pattern. Okay? The light rays will be bent or will be bounced back or will be bounced in one direction only. That is in the specular or regular reflection. In the diffuse reflection, on the other hand, this is a reflection of light in rough surfaces. Okay? The reflection of light in rough surfaces. When your surface is rough, meaning the light that may be striking these surfaces, these irregular surfaces, will be having different direction. Unlike in the specular, there is only one direction of the light rays as they are reflected from the mirror or from the smooth mirror. And in this rough, irregular surface, your reflected light will be of different directions. Hindi po pwede, hindi sila magkakapareho. Kasi, look at the smooth surface and the rough surface. Next, the laws of reflection. According to the laws of reflection, the angle of incidence is equal to the angle of reflection. It is equal to the angle of reflection. So this is our illustration. In our illustration, this is the incident ray coming from the source. When it strikes the mirror, this is the mirror. When it strikes the mirror, it will be reflected, and that is the reflected ray. And in the mirror, or there is this normal line that is drawn, the broken line that is drawn, forming 90 degrees. Forming 90 degrees. Okay? And the incident ray, between the normal ray and the incident ray, the angle of incidence may be formed. And between the normal ray and the reflected ray, there is the formation of the angle of reflection. Now, the angle of incidence is equal to the angle of reflection. This angle is always equal to that angle. That is the first law of reflection. Next, in the reflection in the plane mirror, as you can see in the plane mirror, if this girl's height is 0.1 meter, or 10 meters rather, 0.10 meters, and then the whole of it will be having the same, the image form will be having the same size and the same height, the same distance, as you can see through the different light rays that may be formed. Okay, that is through the plane mirror. Okay, totoo ito sa plane mirror, but not in the other forms of mirrors. Next, the image formed by a plane mirror is always virtual, meaning that the light rays do not actually come from the image. It is always virtual. It is always upright, having the equal distance from the mirror, and laterally inverted. What do we mean by laterally inverted? Okay. when we say laterally inverted, if you raise your right hand in the plane mirror, seemingly you are raising your left hand. That is meant by laterally inverted. And the image is having the same shape and size as the object. Now, we go now in the reflection in the curved mirrors. That was the previous one is in the plane mirror. Now, we have now the curved mirrors. What do you see? Yes, this is a side mirror of a car. And this one? This is a dentist mirror in order to see the inner surfaces of the mouth. Okay? In order for the dentist to see the inner parts of the teeth, that is why the dentist is using this kind of mirror. The objectives that we are to achieve in discussing this lesson, first, we are to predict the qualitative characteristics, location, orientation, type, and magnification of images formed by curved mirrors. Next, to identify ways in which the properties of curved mirrors determine their uses in optical instruments like in cameras and binoculars. Let us start with the kinds of curved mirrors. There are two kinds of curved mirrors, concave and the convex. Okay? The concave mirror is also known as a converging mirror. As you can see the difference between the concave and the convex, the concave has a thinner middle portion. Okay? Mas manipis yung middle portion niya as compared to the sides. And in the concave mirror, when the light rays hit the surface of the mirror, the reflected rays will be converging in the focal point. Okay? In the focal point or the focus. They will all be converging or meeting at one point. That is the focus, and that is why it is called as a converging mirror. While the convex mirror, as you can see, this is the convex mirror. When the light strikes the surface of the mirror, the rays or the reflected rays will be of different directions. They will be of different direction, and if you are to draw them using the broken line from the focus, which is seemingly at the back of the convex, meeting from the back of the convex, they will be moving or pointing towards different direction. They do not meet, that is why it is called a diverging mirror. They diverge. Next. There are two types of images that may be formed. Real image and the virtual image. The real image appears in front of the mirror that could be projected onto a screen. Okay? As you can see, this is the object and this is the image. Okay? Object, image. And the virtual image appears behind the mirror. This is the object and this is the image. It appears to be behind the mirror. This is the mirror and it appears to be behind the mirror. The parts of the curved mirrors, the concave and the convex, there are different parts that you can see there. We have the F, we have the C, we have the P. Okay? So the focal point is this, capital F. It is where the light rays meet. For the convex, this is the F, or the focal point. We have the vertex, the middle point of the curved mirror. This is the vertex, this is the vertex, and this is the vertex as well. We have the focal length, or the small f, the distance from the focal point to the vertex. The distance from the focal point to the vertex. From this point to this point, that is the f, smaller f. And in the convex mirror, from the focal point and to that part, from this point to that part is the focal length. Next, we have the center of curvature. The center of curvature is the C, capital C. And this is the center of sphere of which the mirror is part. Its distance from the mirror is known as the radius. And we have the principal axis of the PA, or most often it is only being referred to as the capital P. This is the line, a horizontal line, 90 degrees from the center of curvature to the center of mirror. From the center of curvature to the center of the mirror, that is the principal axis. Principal axis. Next, the images formed by curved mirrors using the ray diagramming. Rule number 1. Ray parallel to the principal axis will pass through the focus after reflection. In the concave mirror, this is our light ray. Our light ray is parallel to the principal axis. It is parallel to the principal axis. And this is our light ray. It is also parallel to the principal axis. If we're going to draw this broken line there, excuse me, this broken line that may be formed there, it is also parallel to that ray. Next, rule number 2. The ray passing through focus will become parallel to principal axis after reflection. The light ray passing through the focus, when it strikes the surface of the mirror, will be reflected, forming a parallel ray to the principal axis. Likewise, in the convex mirror, the light ray from the source, seemingly forming a line passing through the focus, and when it is reflected, it will also be forming a parallel ray to the principal axis. Next, rule number 3. A ray from the object which passes through the center of curvature is reflected along the same path. This is our object, and the red line is the ray that may be formed passing through the center of curvature, which is at the back of the mirror, would move along the same path, will be reflected and move along the same path. The ray diagram for the convex mirror, the image formed by a convex mirror, this is our object and the image is formed there. It is actually a smaller image that may be formed depending upon the distance of the object from the vertex. Image formed by convex mirror. It is virtual, it is smaller, and upright. The uses of the convex mirror. Yes, the convex mirror is used in the side mirrors of the cars. And another use of it is the one or the mirror that you can see that is put at the corner of a store. Why do you think that these kinds of mirrors are used as the side mirror and the safety mirror at the corner of a store? Bakit kaya ginagamit nila, mas gusto nilang gamitin yung convex mirror rather than using just a plain mirror or a concave mirror? The main reason for that is they have wider field of view. Mas malawak yung pinapakitang view ng convex mirror. That is why ito yung ginagamit sa side mirror ng sasakyan at doon sa mga salamin na nilalagay doon sa mga stores. Convenience stores in particular have this in order to monitor the movements of the customers inside their stores. That is for them to avoid having some things or materials to be taken out from the store na hindi nila babayaran. Okay? So ito yung pinaka-reason kung bakit naglalagay sila ng ganito. Mas malawak kasi ang nakikita kapag ganitong ang salamin na ilalagay doon. Convex at hindi concave. Next, ray diagram for the concave mirror. When the object is placed between the vertex and the focus, the image is this. Okay? So this is the image that may be formed. Drawing the first light ray, reflected, passing through the focus, drawing from the curvature, center of curvature, passing through the top of the object, and be reflected onto the mirror, and drawn a broken line, passing through there. So this is now the image that may be formed. And the image formed in the concave mirror is virtual. It is enlarged, upright. And the uses, it is used as a dentist mirror, yung pinapasok nila sa ating bibig in order for them to see yung inner side ng ating mga ngipin. And the makeup mirror, para mas maganda yung view nung nagbe-makeup. Concave mirror when the object is at the focus. Andito yung object natin, nilagay natin sa focus. And in this particular condition, there will be no image formed. Why? Because of this particular rays, the first light ray that is drawn when reflected passing through the focus, and when the ray passing through from the center of curvature to the top of the object, when it is reflected, it will just be bouncing back at the same path, passing through the center of curvature, without forming a what? An intersection between the two lines. So, in this particular condition, there will be no image formed. And this is true and be observed in the headlights of our vehicles. Ginagamit ito sa mga headlights ng ating mga sasakyan. And when the object is placed between the center of curvature and the focus. Okay? So when the object is placed between the center of curvature and the focus, this is the image that may be formed. As you can see, nagkaroon ng intersection yung dalawang rays. Okay? So, this is the first light ray when it is striking the surface of the mirror. It is reflected, passing through the focus. And the line drawn from the center of curvature, when it strikes the mirror, it will just be moving along the same path at magkakaroon ng intersection doon. So that is where the location of your object, or of the image rather. And as you can see, our image is what? Ito yung object natin. And the image is there. And our image is real because seemingly nasa labas and enlarged. Likewise, it is inverted. Baligtad. How about when the object is at the center of curvature? When the object is placed at the center of curvature, so this is our object, the object that may be formed will also be at the center of the curvature. The image formed is real, same size, inverted. When the object is beyond the center of curvature, nasa likuran ng center of curvature. Ito yung object natin. At ito yung mapo-form na ating image. And the image form now is real. It is smaller, inverted. Bakit smaller? Habang lumalayo itong ating object doon sa center of curvature, mas liliit itong ating image. Now, let us try to evaluate, or let us try to have an evaluation of what we had learned. First, a convex mirror will always produce an image that is blank. A. Virtual, upright, smaller. B. Virtual, upright, and larger. C. Real, upside down, smaller. And D. Virtual, upright, same size. What is your answer? Very good. Your answer is A. The answer is always virtual, upright, and smaller. Number 2. The reason why convex mirrors are used as rear view mirrors in vehicles is that A. It is more attractive. B. It has wider field of view. C. It produces real image. And D. It produces virtual image. The answer? Answer is B. Next, what will be the exact description of the image that will be formed on the given illustration of a concave mirror showing object location between center of curvature and the focus? A. Virtual upright enlarged. B. Real enlarged and inverted. C. Smaller than the object, inverted and real. And D. Smaller than the object, upright and virtual. The answer? Very good. It's letter B. As you can see, when the object is placed between the center of curvature and the focus, our image form is real, enlarged, and inverted. Number 4. Rays of light traveling parallel to the principal axis of a concave mirror will come together. A. At infinity. B. At the focal point. C. At the center of curvature. D. At a point halfway to the focal point. Your answer? Very good. It's at the focal point. They meet at the focal point. That is why this particular mirror, the concave mirror, is also known as the converging mirror. Last one. A candle is placed in front of a concave mirror. The image produced by the mirror is A. Real, inverted, and magnified. B. Virtual, upright, and magnified. C. Real, inverted, and demagnified. D. Virtual, upright, and demagnified. Your answer? If your answer is B, then you are correct. Our answer is the image produces virtual, upright, and magnified. Now, to sum it up, let's have the characteristics of the convex mirrors. First characteristic of the convex mirror is that a convex mirror is also known as a diverging mirror, as this mirror diverges light when they strike on its reflecting surface. It diverges to different directions. Second, virtual, erect, and diminished images are always formed with convex mirrors, irrespective of the distance between the object and the mirror. It is always virtual, erect, and diminished. The characteristics now of the concave mirrors. First, light converges at a point when it strikes and reflects back from the reflecting surface of the concave mirror. Hence, it is also known as the converging mirror. The light rays will be converged at the focus. Next, when the concave mirror is placed very close to the object, a magnified and virtual image is obtained. If we increase the distance between the object and the mirror, then the size of the image reduces and real image is formed. And lastly, the image formed by the concave mirror can be small or large, or can be real or virtual. thank you very much for watching, and we may see each other next time.